Hello and welcome to my D1 revision videos. Today we are talking about Kruskals algorithm. Now Kruskals algorithm is a very similar and in my personal opinion easier version of Prim's algorithm. If you haven't watched that revision video yet, I suggest you do so just to get a bit of context. In the exam, the chances are they'll say to use either Kruskals or Prim's, so you'll have to know both. They both find a minimum connector, and they will both find it of the same weight. It will be the same connector, but they have two slightly different methods. So for Kruskals, you start by selecting the arc of the least weight, along with any nodes that it touches. You then select the arc of the lowest remaining weight that hasn't been selected. You look to see if it creates a cycle. If it does, you remove it, just like on Prim's. If not, you add it to the selection along with any node it touches. If all the nodes are selected, you can stop. If not, you repeat. So it's a really simple, I think it's the easiest algorithm on the D1 paper. Again, for a bit of context, we're going to do a run through with an actual example. So here is our graph. The nodes or vertices are labelled with letters and the arc weights are the numbers. So let's start. Select arc of least weight along with nodes it touches. So that is this arc and these nodes here. 3, because 3 is the lowest value that we have on this diagram. Next, we select the arc of the lowest remaining weight. So let's see. What do we have? We've got 5, 7, 6, 15, 7, 8, 5, 8, 9, 11. So it's going to be one of the 5s. We can pick either. It doesn't make too much of a difference. So let's pick this one, the ED arc of 5. Now we check, does it create a cycle? Let's see. No, it doesn't, because it's not even touching the other selection yet. So it's not. So we add it to the selection with any nodes. So let's do that. We're going to select the arc and the 2 nodes it touches. And now we say, let's have a look. Are all the nodes selected and connected? They are not. So we go back to having a look. The next smallest is 5 here. Would it create a cycle? No, it wouldn't. So we can select this. There we go. Are all the nodes connected up? They're not. So let's have another look. We've got 7, we've got 6. The 6 is the lowest. Will it create a cycle? No, it won't. So let's select that. Are all the nodes connected up? No, they are not. So let's have another look. 7, 8, 7, 15, 8, 11, 9. It's going to be the 7s. So let's just pick this one. Does it create a cycle? Yes, it would. It would create the ABCA cycle you could loop around in. So we delete that that arc. We don't want that in here. So now we look. The other 7 is the lowest. So we'll pick that. Will it create a cycle? No, it won't. So let's select it. Are all the nodes connected up? No, they're not. So we go back, have another look. 8, 15, 9, 8, 11. 8 will be the lowest. There's 2 of them. Let's just pick this one. Will it create a cycle? Yes, it would. CEDC would be a loop. You could keep going round. We don't want that. So we delete it. We go back to selecting. The next lowest is this 8. Would it create a cycle? It would as well. BCEF, a 4 vertex cycle would be created. So we don't want that. We're going to delete this arc as well. Now we'll take another look. The next lowest, 15, 11, 9. It's going to be 9. Would it create a cycle? It would not. So we select this. Are all the nodes selected and connected up? They are, and that means we can stop and draw out our answer. Obviously, it will have all the nodes the same, and it will only have the arcs that we actually selected, which are these. And if you remember from the Prim's video, these values that we have here are actually the same as the Prim's one. It'll get you the exact same answer when you add up all these numbers. So they're both finding the same thing, and that is a minimum connector. So if it asks you to find a minimum connector, you can use whichever one you prefer, Prim's or Kruskals. but most likely it will tell you which one it wants you to use. One thing to remember that I probably should have been more precise about is when I say are all nodes selected, it should also be and connected. So I'm going to write that on there. And that is because it could be possible to have, say this was your graph, just a square, and it had lines here, like that. And they were valued 2, 3, 4, and 5. Well, the first one you would pick would be 2, you'd select this. The second one would be 3, you would select this. Now all the nodes are in a selection. The problem is the two selections aren't connected. So in that case, they are selected, but they're not connected. So you'd still go back and pick the next one that doesn't make a cycle to connect them all up. So that's something to be aware of. But again, for the exam, if you just print screen this and learn this process, there's nothing difficult. It's just remembering what steps to do in what order. So Prims and Kruskals, they're both very similar. If you get the choice, pick what you prefer. I like this one because it's just counting up. You don't have to look back across all your selection and check. But it's really just personal preference. This is probably going to be one of the easier questions on the exam near the start. There's a chance it'll ask you to do both or compare the two, and then you could have to talk about how they get the same answer, but Prims you have to look at your selection, Kruskals you go anywhere. If you're struggling to remember the difference, the way I think about it is Kruskals sounds a bit like Krusty the Clown off The Simpsons. And he's crazy, he just goes and picks from anywhere he likes. It doesn't have to be connected up and all from what you've already selected like Prims. You just go for whatever you want, pick the smallest no matter what it's attached to. That's how I remember the difference. I don't know if that'll help you or not. Again, if you have any questions on this algorithm, leave a comment and I'll try and answer them. And that's really about it for Kruskals. So thank you for watching. I'll see you guys later.